we're in a time of evidence-based practice and medicine, and that's infiltrated every aspect of health research. We want decisions made on evidence, not just pure opinion, whether that's literature evidence, whether that's real world evidence brought in. You can't ask, for instance, ChatGPT what the weather is going to be like tomorrow, because tomorrow hasn't happened and it's trained on previous data sets. So it'll say it can't do that for you. So I think there has to be an understanding too within AI is what the different types of AI can do and can't do. Prompt engineering is getting the system to do what you need it to do. So it's basically the language that speaking with AI, with the LLM, and getting the output that you need from it. I think people look at it a little bit like a genie in a bottle. Like I just have to throw something at it and I'll get all my wishes and dreams will come true and all this will be there. But you have to put some background work into it to understand what it can do. I think we need some understanding about what tools are best fit for what purposes, and then how to ask it to do those things. So it's not a one size fits all at all.
Hi everyone, welcome back to Access Granted, the IMAC podcast. My name is Nicole Tunstall and I'm Vice President at International Market Access Consulting. I have with me Louise Perrault.
Hi everyone. I'm Louise Perrault. I'm the CEO and founder of IMAC.
And with us today is our guest, Dagmara Chojecki. Dagmara, why don't you go ahead and introduce yourself?
Hi, it's very nice to be here. I'm Dagmara, as was mentioned, and I'm an information specialist, research librarian by training. I have 18 years of experience in evidence synthesis, health technology assessment, complex searching, and evidence synthesis methodology, and a particular interest recently in using novel methods with AI for evidence synthesis, and exploring the possibilities that AI can bring to facilitate work on health technology assessment and systematic reviews.
Perfect. Thank you. Thanks everyone for joining us. So as you probably guessed from Dagmara's background, we're going to talk today about the use of artificial intelligence in evidence synthesis in HTA. And we're going to explore it from many different angles, since it's something that is definitely a hot topic and up and coming in the field. So why don't we start off, perhaps, Dagmara, if you can give us a bit of a background of what it is exactly when we talk about evidence synthesis and the use of AI in it. What does that mean?
Evidence synthesis is a notoriously long process. Doing a health technology assessment or a systematic review can take sometimes years. So we gather all the evidence, and that's the piece where I was always involved. Mainly was doing complex searches for all of the research studies and putting all of that together. Also have been involved in the process of screening through sometimes thousands and thousands of results from these searches. And as more and more is published and the channels of publication are more open, there's just more and more of a volume of research out there over the years. So I'm finding that HTAs and systematic reviews are getting larger and larger, and we keep having to kind of rein them in. And so there's a lot of grunt work involved in this, screening through them, picking out the ones that are relevant to the research question, extracting all the data from these studies. And so we're looking at sometimes, a year or more to produce a review. And sometimes an answer is needed quite quickly, whether it's for policy or, the introduction of a new drug that would be beneficial to patients. And so the wait times for these are problematic at times. So AI, I think, is fostering this new opportunity to cut a lot of that grunt work, a lot of that tedious work, such as the screening of thousands of records, the extracting of the data, and allowing us to kind of get into the meat of things and to do more of the intellectual work around it, the creating connections, conclusions, applying to the context that we need the review to be placed in. And so it's really going to facilitate faster, more effective reviews, I think, help to decrease kind of human error in a lot of the tedious types of work that are done, and I think get therapies and medications into the hands of patients earlier on, and really good policy decisions earlier on.
Interesting, and that's certainly something that has been on everyone's mind, especially the last year in the lead up to the implementation of the EU JCA, because as we know, the timelines for that are quite tight, with only 90 days after submission to the EMA. And we've seen case studies where there have been multiple PICO that need to be evaluated. So in that case, it's quite a large evidence synthesis. So there's a lot to get into on that topic. Maybe I would even ask for, in a step back, in a sense, where does evidence synthesis sit in terms of the overall HTA process? So where is it most used?
I feel like the evidence synthesis piece is kind of the backbone for the whole HTA. It feeds into a lot of parts. It feeds into, the economic piece as well. Oftentimes, we gather all the evidence that is there already, all the data that may be produced about already existent about, costs and quality of life and clinical effectiveness. And when we use that to kind of filter through the rest of the HTA. So we've, HTA, I kind of like to look at it, maybe this is a bit of a crass, as a systematic review on steroids a little bit. It's like a big, there's multiple pieces to it. So we've got your clinical piece, you've got your health related quality of life piece, burdens, economics. It's everything around a technology or a drug that would impact when it's implemented, right? And so again, going beyond just clinical effectiveness, and really evidence is our basis for all of that. We're in a time of evidence-based practice in medicine, and that's infiltrated every aspect of health research. We want decisions made on evidence, not just pure opinion, whether that's literature evidence, whether that's real world evidence brought in. So really it's the meat and bones of it, and sifting through all of that, unfortunately, is quite a tedious task. Again, research is exploding, publications are exploding, and keeping up with all of it and searching through all of it is becoming increasingly hard. And I think AI is the solution for us to cut that down and be able to sift through the evidence and organize it and utilize it for HTAs in a much more efficient, streamlined way.
If I understand correctly, AI is not really going to change any of the standards that are actually set for systematic reviews. It's only going to change the speed and how we do things, but the fact that it has to be validated, it has to be reproducible, and all of that is not going to change. This is not a matter of changing methodology at all, right?
No, it's not. It's essentially a tool to augment our work. And I think this is brought out in a lot of the guidance and policies that are coming out right now around AI usage for evidence synthesis in HTA by agencies such as NICE and ISPOR and Cochrane, who set the standards. I think we can think of it like we've always used a spell checker in Word. We don't, as a tool to help us pick out all of the, spelling errors we have. It's another type of tool to help facilitate that grunt work. So I can get a list of all of the studies that I need, and I can ask AI to help me find all of the non-human studies, and it'll help instead of me manually going through, 10,000 articles to pick them out. It'll help to identify those more quickly. That's a very simplified version of what it can do. You can ask it to do a lot of different complex tasks for that screening. But yeah, all of that work that was time consuming and maybe not as intellectually rigorous, I would say, in terms of like it's grunt work, it's laborious. It will cut a lot of that out and let us do that more important contextualizing work, summarizing, creating, the conclusions and from the results, and concentrating on the applicability of those results, instead of, again, screening through thousands of results and extracting, statistics from the studies. And again, too, I think it will help, because the work is laborious at times, there's margins for human error, extracting a statistic that is, putting in a 7 instead of a 2 or whatever when you're doing that and checking it. And I think by programming these systems to be able to identify those easily, we can, mitigate human error in a lot of ways from some of this grunt work that is easy to, oftentimes kind of these mistakes get introduced into. So that's another advantage to that is accuracy in that kind of aspect.
That's really interesting. So I think, well, one of the things that struck me is that, you hear about, of course, AI and the applicability of using AI in different aspects of our daily lives all the time, and it's only increasing. So I have kind of a two-pronged question. I think that there's there's many different types of AI or types of tools that you can use, and I wanted to understand a bit better which ones are kind of most applicable in this area. And then secondly, maybe talking a bit more about, how to use them safely.
So yeah, we like to use the term AI for this all. AI is really a large umbrella term for many different types of technologies, like robots fall under AI. A lot of other programming software used in like diagnostic tools. But when we're talking about evidence synthesis and HTA, we're really talking about large language models. And so what we all know is like ChatGPT is an example of that, or Perplexity uses some technology. And so these kind of tools are language based. And what they do is they identify patterns within the data set. So their data set, they're trained on a data set. So with ChatGPT, as everyone knows, these data sets are massive. So entire portions of the web, other documents, etc. And so they can process all of that quite quickly and find these patterns, and then based on pattern recognition, give you these answers. So it is all language based. And we have to keep in mind too that it all depends on what data you put in, what you get out as well. So, you can't ask, for instance, ChatGPT what the weather is going to be like tomorrow, because tomorrow hasn't happened and it's trained on previous data sets. So it'll say it can't do that for you. So I think there has to be an understanding too within AI is what the different types of AI can do and can't do, right? It's pattern recognition again. So it can't create these new novel ideas or conclusions because it's based on things that have already been, right? So these tools are great for summarizing evidence. Again, you've got to as well recognize when you want something summarized, you've got to feed it the data as well. So oftentimes if you want a bunch of articles summarized or research, that you've got to give that to them. There's copyright issues you oftentimes have to consider as well. These models sometimes don't have access to full texts of papers because they're behind paywall. So if you do, kind of I call them a quick and dirty search and just ask the system to, provide you background information about a new diabetes drug, remember that maybe it doesn't have access to all of the research as well. You have to kind of feed it sometimes and through what we call prompt engineering is prompt it to provide you the right, to look at the right information and summarize that. So there's some nuances there. But yes, it's when we're talking about AI, it's really these tools. So and there's various ways you can use a lot of these tools. ChatGPT is at the forefront right now, really. And that's the one that's being talked about, I think, everywhere. And there's various ways to use ChatGPT, and I think everyone's familiar with just the kind of black box method with what they call it. So you just, go in and type in a question, very Google-esque. And I think we treat it almost like a Google search engine at times, which it is not. And that becomes the problem because it doesn't just respond the way Google does and provide you with everything. And you have to, know how to ask it something in series of questions and refine it and really teach it for what purpose you want the information for. So you want it for a report, you want it to be academic and scholarly in nature, or you want a list, or you want a table. So there's a whole process for using these LLM models where you have to really teach it and train it about what you want coming out of it, its form, the function for it, and you have to put in something. And this came up recently in a conference I went to, and I think it's really important. You have to give these systems guideposts. So you have to tell them what you don't want as well. So I know there's a lot of critique of using AI and LLMs for research because of hallucinations, as they call them. So, a good example when I was first playing around with AI was and seeing what it could do, like when ChatGPT first came out, was there's a book by a Swedish author where it's like a whodunit mystery case. And it never says who the actual murderer is, but it implies it throughout the book. So I asked the system, ChatGPT, who the murderer was, and it took 7 tries, and it made up whole parts of the book and story, and that weren't true. So it kept saying, "No, it's not. No, it's not." So these are these hallucinations, is that it tries to give you the best answer possible based on patterns or other within the data that it sees. But you can give it a guidepost saying, only give me responses that are certain, or how much certainty do you have? And, you need to mitigate some of the risk and understand what is going on behind the system there and how these LLMs actually function.
And we talked about the kind of the big kind of global ones. What about ones that are designed specifically for the purpose of evidence synthesis? So these would be, I guess, closed models then, ones that you are training with the data set?
There's a lot of proprietary systems, different models that people have developed. Companies like DistillerSR, Elicit is another company right now that is, claiming that they'll do a, 5-minute systematic review for you using AI. So they've kind of built in the programming and using the large, the functionality of a large language model that you can then, they take that and they've already pre-programmed it to do the screening or pre-programmed it to do data extraction and all of those tools. So everybody's kind of hopping on the bandwagon and utilizing, so the large language model or the AI is really kind of the engine, and then they're building the infrastructure and the car around it for researchers to use for those tasks. So there's these pre-programmed, ready to go already, tools that are easier to use. But a lot of, I guess, more programming savvy, technology savvy individuals in even in health economics and in the research world, they're building their own too. and getting expertise in that prompt engineering piece where you can really customize. But the back end there, that engine really is, and there's really only 4 or 5 large language models. So OpenAI's, what ChatGPT, the actual ChatGPT is kind of the front end. It's like the your driver's seat sitting in them, but the engine is the GPT, and then there's other ones called Claude, or Google also has one, and then there's that Deep Think, I think it's called, out of China. DeepSeek, yes, out of China is that one that was competing with. But those are the actual like background bones AI systems that are doing like the word crunching, as you could say. And then everybody's kind of building systems on top of that, using those to do the work. It's exploding, and everybody is trying to create tools, various types of tools for various purposes. It's moving so quickly that I don't think anyone is able to keep up. Even at the last conference at ISPOR, a workshop that I took there, I think they had prepared slides 6 weeks earlier, and a lot of them were obsolete already, with tools being out of date. So sometimes even for me to list particular tools that are helpful, somebody will go into it and it'll have completely changed. So
yes,
yeah, so
amazing.
It's monumental speed. Everything is changing, and new tools are popping up all the time. So I don't know if that provides much guidance for people on which ones to use. I guess, for me, mostly ChatGPT, and then now going into using kind of more prompt engineering and customizing the GPT through an API is what I'm investigating for various purposes. So what we know is we've identified within the systematic review HTA world specific tasks that these tools are really good at doing. And we can build our own, organizations are building their own systems that are context specific. So oftentimes it's, one tool won't do it all for you. It's very context specific.
Right. And you mentioned prompt engineering, and that is something that we hear a lot about recently. And I am wondering if you can explain exactly what prompt engineering is.
Prompt engineering is getting the system to do what you need it to do. So it's basically the language that speaking with AI, with the LLM, and getting the output that you need from it. And so I like to kind of say, like, garbage in, garbage out. If we don't ask it the right way, we're not going to get the output that we need. And it is an art. It's a and I've seen a lot of literature about, it can be complex at times. And some people need to know a little bit of programming language. Some systems facilitate that, but there's a lot of frameworks and strategies for optimizing your asks of the system. So I think, I've done a little bit of reading just about where prompt engineering is going, because I know it's the hottest topic recently, and it's the hottest career track. I think I saw a job posting where it was, salary starting at 300,000 American for a prompt engineer so it's very desirable, and there's prompt engineering streams coming up at universities. And for now, it is being touted as one of the most important skill sets to have going into the future, is understanding it's basically understanding how to use these systems to their most effectively to mitigate those hallucinations, and to get the correct outputs, because they are capable of so much. We just need to know how to ask them correctly and how to train the system to do what we need it to do at the moment. And I think over time, as more advances in this whole field start coming in, it'll be less complex. The prompting will be, streamlined, and we'll figure out better methods for it. Right now, it is clunky. You do have to know a little bit of Python or other programming languages at times, especially if you get into really complex multi-step kind of tasks. Like I think we walked through creating a econ model at ISPOR, and that is a very complex process where having programming language in your back pocket is needed, but it's still needed, I think, in using ChatGPT. Even I think everyone has sat with ChatGPT and you're just getting the most ridiculous answers, or it's not doing what you need it to do, and you're frustrated, or you see a hallucination, and then oftentimes, people then will start to also label it as unreliable. But it's really because you're not asking it the right way, and
Yes.
getting, speaking its language. So we're learning ChatGPT's language and how to ask it correctly.
Yes, thank you. One of the biggest issues, I think, at the HTA level with evidence synthesis and systematic literature reviews is reproducibility. And what are your thoughts on the use of AI and reproducibility? Does it hinder it? Does it help it? Or is it, again, about knowing how to use it?
I think a lot of it is about knowing how to use it. And I think prompting is a big piece in that. I've tested it out, and you can ask, one question one day, and then go back another day and ask that same question, and it can change depending on previous searches. And but again, with proper prompting, there's ways around that, and there's proposals for the creation of what we call prompt libraries within evidence synthesis. So prompt engineers can develop ideal prompts and set of prompts and processes that can ensure that there's consistency, reproducibility, and that's a whole new field that's emerging within all kind of organizations in all fields. Is prompt engineering within organizations, developing prompt libraries for the organization to ensure consistency across workflows. So that's something I think we will start seeing more of as we kind of work out kind of the best practices and methods for those prompts. I think it's still kind of in its infancy, but I see things moving that way for sure. Again, I think all of this, the consistency, the minimizing risk of hallucinations and mistakes, it's all in the prompting, I think.
Right.
And the more I learn about prompting, the more I realize that effective prompting skills are really the future. So again, I think as well, that's all emerging. Best practices are emerging and changing as we learn what these systems can do and can't do, and as they change themselves too. So it's a evolving field, and it's very exciting.
Yeah, absolutely.
So that leads really well into my next question, which is more about where are we at now at the kind of the bigger HTA agencies. Maybe both you and Louise can comment on where you think they are in terms of accepting AI. What are some of the guidelines that are being put together? And maybe just a comment on where you think it might go in the future for them.
I think we're really at the beginning still. I think a lot of agencies have yet to comment. Some of the larger agencies, like and organizations like NICE and ISPOR and Cochrane that I mentioned, have put out policies. These policies are slowly starting to pop up, I find, as more and more organizations address AI and just the prevalence of it. And, you know, it's the hottest topic, I think, in any conference we go to now. I think it's dominated by AI sessions. But it's cautious optimism, I think, for the most part, but excitement about it. So, and I see all the policies really emphasizing that AI is not to replace human work. It's not to, again, it's just to augment it and to make those more laborious tasks easier and cut the time there. Also, they really emphasize accountability, human accountability for the AI. The AI is not the author and is not doing the work. We still are accountable for the validity and reliability of the work we do. And so that involves checking, that involves ensuring, you know, this tool is used properly, and disclosing. Disclosing is a big thing. And I think this affects all parts of society with AI. Is, you know, it's a bit of a wild west still, but I think there's more of an emphasis that if you use AI, you disclose that you used AI and how you used it and for what purposes. We're proliferated right now with these deep fakes, and I see them in the news, you know, AI used. And I think policies coming out of the EU especially are really emphasizing disclosure of AI. And if AI is used for any sort of publications or public-facing content, that it has to be legally disclosed, and otherwise there's fines, and quite hefty fines. So in the EU, the EU right now has the first passed legislation on AI under the European Union, where that is really emphasized. So that applies to us as well in the HTA and systematic review evidence synthesis world, that we're sending these products out to the public, and we do need to then disclose how it was used, why it was used, and how we mitigated risks related to it. NICE also really emphasizes disclosing and discussing how any sort of risks were mitigated. And I think that all comes in with proper prompting, right?
Mm-hmm. Yeah, I mean, I see some similarities to, you know, and we've discussed this before when searching databases. One of the reasons why we document very well the date range that we're using is because even searching a database, you know, a few days later, if you're not using specifically the exact same date ranges, you could come up with different results. And I think, if I'm not wrong, even if you do use the exact same date ranges, you might have some differences in the results because of ongoing upkeep of the database. So in a similar way, there needs to be a lot of documentation that goes on when using AI.
Exactly. And I think we're used to that. We rigorously report our methods, you know, to show their validity, and to show that we've followed guidance and best practices. And the same, you know, there's going to be guidance and best practices on the use of AI. This is all forthcoming. We're working all this out. But it's going to be about disclosing how and why we've used it, and being transparent. And I think a lot of that isn't happening yet, because it's very much a wild west still, and there's starting to be some guidance coming out on how to disclose and what to disclose as well. So I've seen some frameworks for that, and that will be important too. It's interesting that you mentioned the searching piece, because this is really why I got interested in AI and prompt engineering, because I feel like it's really a continuation of, you know, it really is linked to my work, where I do the complex searching in a lot of these databases, and I formulate the asks, the prompts. So, you know, I've essentially been prompt engineering for the last 18 years, and it existed before, right? But it's just a new system and understanding a new language for that. So I see that, and I've spent a lot of time teaching students at the University of Alberta on how to effectively search Medline or PubMed, and seeing their difficulties and frustrations with getting, their articles out of it, and not understanding how the system works. So now I see it's evolved now into watching people become frustrated and with ChatGPT and it hallucinating. And so I see a connection there about helping people to understand how to ask the system to get what you want, how to ask it properly and speak the language there. So I'd like to connect people to the systems and teach them the language. So I'm like to be the AI translator, I guess, in a way, and help organizations and those involved in evidence synthesis to use the systems. It's a mouthful, to their full potential, because I feel like people don't realize what it can do. It's because they don't know how to ask it the right questions, right?
Yeah, I think also because the talk out there is, oh, AI can do everything for you. And people think, oh, wow, let me get onto ChatGPT and ask it to do whatever I want it to do. And they don't get what they want. They get frustrated and they stop right there. I think it's important that people understand that there's an investment in time upfront to put into learning how to prompt these models efficiently. Although I'm not at the level where you are, Dagmara, but I've spent countless hours on these tools, and the more time I spend on a tool, the more I appreciate the models, because I can dialogue with them in their own language and they get me what I need. So I think a lot of the frustrations come from what people are hearing everywhere, and when they sit down and play with it, it doesn't fit the purpose at all.
I think so too. I think people look at it a little bit like a genie in a bottle. Like I just have to throw something at it and I'll get all my wishes and dreams will come true and all this will be there. But you have to put some background work into it to understand what it can do. And again, like different models and different interfaces. So ChatGPT is one interface for the GPT model, right? Are good for certain tasks, right? If I'm going to create an economic model, I'm not going to do it through ChatGPT, right? I'm going to, have to download an API, which is like a software to talk directly to the model, bypassing ChatGPT. ChatGPT is almost like a pre-programmed, there's some pre-programming in there, and it's a more basic version of GPT of getting to the model, right? It's like an interface for a user, which is used for not as complicated tasks as, that require a lot of data crunching, like something like building an econ model that has multiple complex steps to it. So you'd use a different sort of route and tool to get to use the LLM for those kinds of tasks. So I think we need some understanding about what tools are best fit for what purposes, and then how to ask it to do those things. So it's not a one size fits all at all. So, and I think that's a big misconception for it. And then when it fails or it hallucinates, people poo-poo it, and it's not reliable, it's not valid, where you're not providing a guidepost, you're not telling it to what you want it to do and ensuring that it does it the right way. So I think we all, and I'm not, I have some expertise, but I'm not by far not yet a total expert, and I'm continually learning, and it's evolving as well of, how I can kind of harness all of this.
Yeah, that's really interesting. And the way you put it is exactly what I think people interpret when they hear things at conferences or, maybe in a sales pitch, that there is ability to do an SLR in 15 minutes or something like that. You kind of get this impression that it's just it's already there and it's
Yeah.
ready for you just to have that information. But the reality is that the amount of work that goes into, as you say, the programming and the guide, giving it guideposts and all of the kind of harnessing that you have to do to the model to get it to do what you want it to do. And then the human part of reviewing the material and ensuring that it is what you wanted and contextualizing and synthesizing. At the end of the day, there is obviously there's time saved, but it's not a reduction of 100 hours to 15 minutes, which is, I think, sometimes the impression that it gives.
Exactly. I have yet to see a system that could do that. And in a lot of the presentations on various different tools that are developed, there's still a lot of bugs to be worked out, and a lot of mitigating of problems and issues and risks still involved in using these systems and setting them up, that I've noticed. So it cuts some time, but it's not, at the point where it can just spit out a systematic review in no time. So the human work is still essential, and I think it'll always be essential. I don't think these systems will ever into the future just totally take over and be able to do what we want. There's always going to be an ask and a human need that has to be translated. And someone is always going to have to feed the data to the system to learn on. So there's still like a big role that involves our brains to work with the tool, right? So it's like our brains are still valuable, and there'll still be humans involved in systematic reviews and health technology assessment, just in, different ways, I think.
Mm-hmm. Different capacities. Yeah. And I guess the value of experience is still key.
Well, exactly. So I heard this at a conference one time, is that non-experts in a field should not be using AI because of that validation piece and understanding. It's a tool for the expert to cut down the grunt work. So then you can look at it and you can, the expert will see and read it and say, well, that's not right. I have to refine it. Whereas a non-expert, if I went in, I'm not an economist, and I said, build me an econ model on such and such, right? And I would look at it, I would not know what's wrong with it. And I would, not be able to refine or ask the right questions to create a good economic model. So really, AI shouldn't really be used in this context to replace the work of an expert. An expert should be using it to refine their work and to make it easier for them.
Mm-hmm.
Interesting.
I think it's great to have this understanding, and thank you so much, Dagmara, for walking us through such a big topic and all the different ways that when we discuss the use of AI in evidence synthesis and HTA, it can seem very overwhelming. And I think you did a really great job with kind of walking us through some of the big topics. And it's great to hear that at the core of everything is expertise, is human expertise. And without that human input or that human expertise, really these tools are meaningless, because we only can get out of them as much as we can understand. And you need that expertise in order to interpret and understand what is coming out from some of these tools. So I think that's great to hear. And I mean, this is such a big topic. I think that we could talk about it again and maybe deep dive into some of the other aspects coming up. So look for a follow-up podcast on this for sure. But thank you so much to you both for joining.
Thank you very much, Dagmara. Thank you, Nicole. This was a very an excellent session. I learned a lot. So thank you very much.
Thank you so much for having me. And I just like to leave with a sentiment that the robots are not taking over, that we will not become obsolete, and that I think AI is not all doom and gloom, and I think it's actually a positive for our future and for getting healthcare decisions made in a more timely manner and improving health outcomes for all of us, really. So I think it's a tool for good versus evil, for sure.
Great.
Great. Thank you.
Awesome.